Okay, very good morning, everyone. This is Umang here, and we are just checking the system right now. If you guys can hear me, if the video is pretty clear, if there's no lag and all, I would love if you could put in some chat, whether you guys can hear us, see us, and all that, so that we know things are up. And then we will go live with speakers. So Sahil has already joined here with us. We'll go live in a minute or two. But before that, we'll just have a check whether everything's visible, everything's good. Okay, so Madhu has replied, all good, sir. So that means we are good to start. So, guys, we'll wait for one more minute as it's a friendship day. First of all, happy friendship day. A very good morning. And yeah, why not get all your friends up, get them join this session, because let me tell you, this is session which will help you define your career. This will help you understand what happens in the industry. Okay, and yeah, I mean, I'm sure you or your friends wouldn't want to miss this. Okay, this is something which is going to be pretty cool. So we'll just wait for next 30-40 seconds or a minute. Then we'll go live with Sahil. So before that, yeah, you have few minutes to, or few seconds rather, to just get up, get friends, get anyone who said they would be joining. Okay, and then we'll be hitting live. Cool. So I think we are good to roll now. So again, very good morning, everyone. Very good, happy Friendship Day. I believe you and your friends are having good fun. Also, good fun learning with us with the Byte event as well as in general as well. Uh, Hopefully, you are keeping safe, keeping healthy. And with this, let me introduce Sahil. So, Sahil is a very dear friend. We studied together at IIT Madras, and his journey is definitely a motivation for anyone who is looking, who feel that can I do it? And Sahil has done it. Okay, so he started with mechanical engineering. He got a pre-placement offer at ITC, which as a core mechanical engineer. He worked there for, I guess, style 1.5 years, and then he went to Stanford to do masters, and from there on he joined Walmart as data science engineer. So a complete shift of mechanical to data science, and after a year at Walmart, now he's a machine learning engineer at a normal security. Okay, so he has taken the journey. He has done it in the best way possible, and now he would be in today's session walking you through what it is like to be a machine learning engineer in the industry. Okay, what a machine learning engineer does, and definitely this is something which would help you take your career choice, or take an informed career choice. Okay, with this, without any further delay, I will be handing over the session to Sahil. Sahil, all over to you.
Thanks for that kind introduction. Good morning, everyone. I hope you guys are having a good friendship day. And I will like to walk you through my journey of what it has been like transitioning from being a core mechanical engineer, not having any idea how to actually code, to be honest, before I started this. And from there to actually become a machine learning engineer, a data scientist actually to begin with, and then transition into machine learning engineering, and doing this as a day-to-day job now at Abnormal Security. So should I go ahead and share my screen, Umar? Okay. Cool. Okay, and then let me know if you guys can see it. No? Okay, perfect. So the idea of today's session is to walk you through what a day-to-day looks like in a machine learning engineer's day, essentially. All of us fantasize about this job as a very rosy-eyed picture of you're cranking out code, you're writing BERT models, or you're writing the next generation architectures or machine translation or whatnot. But the reality is very different. And I'm sure you would have heard a little bit about it in the different sessions that you have already had through this bite sessions. What I wanted to do then differently was actually to introduce you the hard things about being a machine learning engineer. The hard things about actually doing it as a job rather than doing it as a research project. And what are the difficulties and challenges. And then hopefully that allows you to make decisions as to whether this is something for you or whether this is something that you think, imagine yourself actually enjoying doing as a full-time career. I hope I'll be able to convey that through this presentation. And at the end of it, I'm happy to take questions about my journey, about managing these projects, etc., etc. What I also hope to give you is a sneak peek into what being a machine learning engineer looks like, what being a machine learning engineer is like in a high-growth typical Silicon Valley startup. So the company that I work for, Abnormal Security, is a cybersecurity company. It was founded about 3 years old. I've been with this company for almost 7 months now. And it's been an amazing journey, and I think I have grown a lot as an engineer with this company, and I'm going to share some of my experiences that I have had through this journey. So there are two main things, as I said, we will cover. Let's say you're already in an ML job, but you have no idea what it's really like, and now you're expected to actually ship code, you're actually expected to ship products. And it's a hard thing to do. So I wanted to make sure that I give you an idea of what it's like, even though you're not there right now, but just give you like an idea, paint a picture for you of what it would be like. And the second thing is, I guess most of you are still students, second year, third year college, and you're thinking about going to ML, and you want to pursue that. Do I have any tips for you? So I'm going to actually spend like the last 5 or 10 minutes just giving you my tidbits as to what can help you to move into this field. As I've already mentioned briefly, one of the main reasons I wanted to talk about ML project management and like a day-to-day in an MLE's job is when I was in college and when I was looking for a future career, I would have really appreciated if my third year or fourth year, when I was making my career decisions, someone would have actually walked in and told me what it's like to be a mechanical engineer at ITC, what it's like to be a data scientist, what it's like to be a product manager, and all of the other different options that I was evaluating. And I took that as a very strong learning. And from that point onwards, when I was doing my grad school at Stanford, that was something I always kept asking people when I met them who were actually doing the job. There's no better person to learn from other than the person who's actually doing it on a day-to-day basis and is willing to share what it's like. So that was always my first question is, what does a day-to-day look for you? And when you ask it to enough people, you can actually start seeing patterns as to what does typically day-to-day mean for that job. And that kind of like answers the next question for you, whether this is something that I want to do or not. So for me, obviously, the fact that I'm doing this is something that I enjoy doing and I'm excited about. I enjoy the challenges that come with it. And I will try to give you some understanding and idea of why these challenges exist, what is the road forward, and how can we, in our future, in our career, better manage these challenges. So roughly the storyline would be, why are we doing this? What does a typical ML project lifecycle look like? I'm sure there are like hundreds and thousands of courses online that teach you ML, but there are very few courses probably, or very few people who can teach you how to do ML in a job, or how to do ML on a day-to-day basis where your product relies on ML for your business to run. The difference between MLE and software development, what makes it hard, as I've already mentioned, and then some solutions, some techniques that I think can help you. Most of it is going to be my personal opinion, my experiences. So I don't expect you to take it as a matter of fact. I expect you to take it as a guiding light, as something that you can inspire yourself for and figure out and find your own facts and discover your own calling in your life. So the first thing I want to start with is the grow up moment for ML has arrived. And what I mean by that is, for a long time, and actually machine learning has been there for ages. It's not a 2010 thing. It's been there since 1960s, 70s. AI has been talked about multiple times before. And there have been multiple times when it has failed to live to its expectation. And fortunately, that has not happened this time. But there was a transition that happened in machine learning where everyone looked at machine learning as the next silver bullet for every problem that they had in life, and that it would magically solve everything. And then there was a very clear transition where that grow up moment came for machine learning, where you're not doing just research anymore, or you cannot just spend an infinite amount of money to solve a problem, but you need to do something in a way that it's marketable, in a way that it's sellable, and in a way that it is sustainable for a business to operate on. And I will explain what each of these things mean basically during this presentation. But that I think is a key takeaway from what I want to tell you in the next 2 or 3 slides, is that it's not your own toolbox anymore, where you can do a nice Kaggle project and throw the most expensive models at it, or like ensemble 100 different things, and then get a nice PR AUC curve or get a nice accuracy, and just clap your hands and say job's done for the day. That's not how this works anymore. And you need to understand and realize that the industry is in a very, very, very different shape right now. So again, this is very my personal understanding of how this industry has evolved. I think I'm broadly right when I say this. The timelines might change by a few years here and there, but think of this more as a directional thing of where this industry is headed rather than focusing on the numbers. But the core idea here is that all the way back from about 2007-8 to about 2015, a lot of the boom in machine learning was around all the new models that were coming in, all the new architectural improvements that were happening, the boom of cloud computing, the advancements in hardware technologies, in accelerated compute that allowed us to actually consume insane amount of data, and then not just consume that data, but then also run like these parameters with crazy amount of parameters, and actually solve problems that initially was just thought to be impossible to be solved by machines. For example, there's a Stanford question answer data set. If you guys don't know about that, you should definitely look that up. The data set essentially is you present a paragraph, you ask a question, and can the machine find the answer for that question in a paragraph? It seems like a very simple task for a human being to do, but it used to be insanely hard for a machine to do till only about 5 years ago. And the fact that all the advancements that we made that possible for a machine, not just that, but in computer vision, self-driving cars, there was just so much excitement around this that what happened from then in 2015 to 2019 was that ML became that silver bullet that everyone thought will solve all their problems. And this is never good for any industry, because when that happens, people just expect to hire some ML engineers, hire some data scientists, throw a problem at them, and then magically expect answers to come out of this system. This is not how anything in the world works. And by the end of 2018, 2019, companies and businesses very quickly started realizing that. This is also the time when most people in the world, most people of our generation, like all the kids who were getting either out of college, either already in their jobs like myself, started thinking about machine learning, started thinking about switching their careers into machine learning, because it was the hip thing to do. It was the next best thing that people could think of. And this is also something I will come to when I talk about my experiences and how I transitioned into this. What I have seen as a marked difference since like late 2018 to 2019 is that companies have actually started realizing that it's very, because of all the open source code that's coming out of Google, Facebook, OpenAI, and all of these companies, it's becoming increasingly easy for them to hire people who can just do Python pip install, or like import a package, import BERT models, and you can literally write 3 lines of code now and have like the most state-of-the-art model running for you. So that's not the hard part anymore. The hard part now is how do you understand which algorithms, which model actually work with the data set that you have, what kind of data set do you need for that, and then what products can you build on top of that, and then what kind of improvements you can make on top of that. So as soon as companies started realizing that, they started investing in not just hiring people who have a better intuition of that, but also people who can not just throw models and get cool results, but who can also think about productionizing the system, about actually building a revenue stream from this such that it either solves a very tangible problem for the business or actually opens up a new revenue stream for the business. So that's roughly the evolution that has happened. No one knows where it goes from here. But the way I see it evolving from this point onwards is you would have to be more flexible in the skill sets that you develop. You have to be more flexible in the way you solve these problems, because the algorithms, the models, the techniques will keep changing, and you will have to keep evolving with time to make sure that you don't stay behind. And when I say that, it's not just algorithms, it's also the entire software engineering toolkit that goes along with it. I don't have it here, but there was a very nice image that was used by Andrei Karpathy in one of his presentations. So Andrei Karpathy is a PhD student who actually made the first ever deep learning class for computer vision. So he was a PhD student at Stanford, was then hired by Elon Musk for Tesla, and he now heads the computer vision department or the self-driving department at Tesla. And there was this really nice slide that he made that I had a pleasure to once attend. And that slide beautifully showed where and how ML fits into the overall stack of like an actual product. And ML is a very, very small component of like what goes into shipping an actual industry product. So it's very important that if you want to stay relevant in this industry, you cannot focus yourself just on the next linear regression models or like the next BERT models or whatever the next architecture is. But you also have to think about how do you actually productionize it? How do you actually, do you even need that? Are there simpler ways of solving a problem? So there are things around that you would want to think about. So what this means is essentially, as I've already mentioned, it's not just a cool and fancy research project anymore, right? It's not just some really smart and brilliant engineers or PhD students working at Google Brain or DeepMind or the Facebook AI Institute. It's not just them. It's not just PhD students at these fancy universities. But it has become a day-to-day thing. Most of the products that you today use actually have some machine learning tool working under the hood. Whether you're writing a query on Google, whether you are searching for friends on Facebook, whether you are on a dating app swiping for your next date, or whether you're working at a company like mine, which is a normal security, which is trying to stop cyber criminals from having companies as a hostage for all the cyber crimes that they do. So it has transitioned from being this nice fancy side project that you would do to actually something that's tangible and that drives core product functionalities and also revenue stream. So for example, my company, the detection team that we call, it is essentially the core engine that drives the product that basically catches all the email attacks that come in. So whether it's phishing, whether it's spam, whether it's like fraudulent attacks, scam messages, all of this is driven by this core engine that's extremely and very heavily reliant on machine learning and AI technologies. So every time we don't do our job well, there's actually a company out there that is at a high risk of actually now being held hostage by a cyber criminal or losing sensitive user data or customer data to these cyber criminals, which can then be used later on. And all of us have heard so many stories about Facebook data leaks or like LinkedIn data leak, or recently there was like an Air India data leak. So we keep hearing of stories about this data leak so often that it has become increasingly important, at least from like our perspective. The reason I tell that story is to really drive home the point that machine learning now is not just, that precision recall number that you want to optimize on and just get a trophy award by having the highest precision or recall. But you need to think about how do you be on top of your adversary or top of the changing trends that's happening in the industry such that your product can keep delivering the value that your customer is paying you for, and hence your business revenue streams are protected, and then the company actually can survive, basically. So it's as quintessential as that. And then the natural flow from there is, once you have something that's very well ingrained into the product, you need to have development cycles, you need to have improvements, you need to like add features to it. Once your customers start using things, they will have more use cases, they will ask for more feature improvements and feature requests. And you need to have a very, very good understanding of how your ML system fits into your entire product stack so that you can now start thinking about whatever new feature requests are coming, are they even doable or not? If yes, how would they work with your existing stack? If not, why not? What changes do you have to make to your system to make sure that going forward you can include such requests and add those features, etc., etc. So it's a very evolving process, and the reason this whole space is yet very disorganized, or not many people knew. So one of the reasons I wanted to put this slide deck together was also because it's hard to find something like this online, right? Because this industry has basically been there for about 4 years, and everyone is figuring it out on the fly. It's like building the plane, learning to fly while you're actually in the sky. And then what that basically means is there are no frameworks, there are no tools, and everybody has their own way of doing it. So there's no standard way. So what I'm trying to do here is just introduce like my philosophy. And I would actually be wrong when I say my philosophy. All of this is very inspired by a lot of my co-workers at Abnormal Security. Joshua, who's like an amazing founding engineer at Abnormal, and I've learned a lot from him as to how to do this. And a lot of the ideas that I'm presenting in this slide deck today are actually borrowed from him. So I have to thank him when I do this presentation, actually. Which is another thing I would like to point out, where when you look for career in this field, one of the things that you would want to look at is how do you be in a place where you have these people around you who can actually teach you how to think about this in such a structured way and hence solve those problems. But coming back to the topic. So essentially, so far I've just motivated why this is a problem and why this is something that even you as a student who's in the second year, third year should think about. For you, it would be like, wow, this is so far away. I'm not even into machine learning now. I don't even know whether I want to be a machine learning engineer. And you're talking about what a job in machine learning, what are the problems in the job in machine learning. The reason you would want to know that now is because of the fact that the job is not, for the lack of a better word, as sexy as it is presented to you, right? And there are real problems, real challenges in this job, challenges that no one has real answers to. And you have to be very prepared when you think about building a career in this field. And that is one of the main motivations why I want to share this with you today. So even if you're in your second year, third year, or maybe even first year, and thinking about taking classes in these fields, these are also some things I want you to keep in mind, and that will also help you to prepare and modify your approach to when you learn these systems and think in the right direction and in the right way when you're trying to build those skills. So hopefully you try to get that out of this presentation. So this is how, this is again borrowed from Jesh, and this is this idea of like how a machine learning engineering project lifecycle basically goes. So typically, you identify a problem. The identification of a problem has to be data motivated. You cannot just say, I believe, or I think that this should do better than that. And this is something we have seen very often happen in especially large companies, where because a senior director or because a VP believes a product should behave in a certain way, or he does a query and that query does not give him the expected result, they will come back and hammer their engineers and say, why is this not doing what I expect it to do? That should never be the motivation of a problem. The problem should always be motivated by data. What motivates that? What in the data motivates that this is an issue that is worth solving? Once you have identified that, then it is about experiment design. Even before you can go to experiment design, you would have to like dive deeper into this data, really understand what's happening in this data. What are some of the things that make you believe that this data is the right data to solve the problem? And what sort of like feature engineering you would need to do that. So that's where this entire experiment design and data wrangling is sort of it's a very gray area. It's like a mix and match thing. So you do some before, and then you do experiment design, and then you realize some things work, some things don't. You come back, you do data wrangling again. This parallel component here. So sorry, give me 1 second. So this parallel component here that you see with the software design and implement software. The reason we include that here in machine learning engineering is when you're thinking about data wrangling, when you're thinking about the software design, it's not just about implementing a model. It's also about thinking what software, what tools you need to build so that you can do this in a scalable way, in an efficient way, and other people in the team can replicate your work as well. So it's not just you open a Jupyter notebook, do some stuff that you have to do, get the data, get the model, do something, and that's not the end of your job. You also have to think about the software design, about how would you implement it, which makes it that much harder because there's an added dimensionality of uncertainty to your project now. And I guess the later part of the later part of this life cycle should be fairly straightforward to most of you. Once you know what the experiment design is, once you know what your data should be, then all you're doing is trying to train models on that, get some results. If they meet your expectation, you go back. You go forward. If they don't meet your expectations, you go back. You rethink what the experiment design should be, where it went wrong. The reason this cycle is important, and the reason why there's so much emphasis on data here, is the fact that when things don't work out the way you expect them to, if you were treating this whole system as a black box, it would be very difficult for you to understand why things didn't work out the way you were expecting them to, which would make it that much harder for you to go back and figure out what change you should make. And this goes back to the point of why it is so hard to manage an ML project is because of all of these uncertainties, right? Because you never know whether the solutions or the experiments that you're thinking about are actually going to give you the result. And if they don't, you have to go back to the drawing board and rethink your entire design and rethink what will work. And in order to do that, you need to have a very very good understanding of what the problem is, what the data looks like, which is something that not many programs will teach you, not many courses will teach you. Everyone will assume that the data is there. Most of the Kaggle projects you do, most of the class courses you do, you will have very clean data set. Essentially, the main problem that lies in a machine learning job is assumed in so to say, in a class project setting. And that's why it's important to dive a layer deeper into this project lifecycle, essentially. So these are some of the points I already touched. In an ML project, there are just too many unknowns, right? There are too many ways in which a problem could be solved, and there's always a better solution. So you can be spending infinite amount of time on a problem, and there could still be a way to solve that problem in a better way. So it becomes very, very difficult for you to actually time box the effort that you're solving, the effort that you're putting into solving a problem. How do you basically narrow down the scope of the problem, or how do you narrow down the possible solutions that you're going to explore in trying to solve this problem? How do you figure out which solutions to abandon once you have experimented with some other solutions? How do you find relationships between these different solutions? How do you trim down your exploration space as much as possible? And how do you basically set yourself up for success? Or in the case there's going to be a failure, how do you identify failure modes as soon as possible? The other most important thing about this job, which makes it very, very hard, is the fact that you can do everything right. You can plan it well, you can have all the right data, right algorithms, but there are still cases where you might still not have success. And this is what makes it extremely hard and extremely difficult for a lot of the folks in the industry to assimilate, because, as I said, this industry is about 4 years old. So most of the managers, most of the senior people in the industry of forming companies are actually people who have never worked with machine learning systems before. So it's very hard for them to comprehend how could have you worked for 1 month on a problem, spend so much time, and you're saying you did everything right, but you still don't have a solution. And then that's a dichotomy that you have to work with. So it's very important to have the right managers and the right people working with you so that they understand that this is a fair possibility. And it's always a research, so to say, it's always a science rather than a technology. And that is basically the crux of what makes it so much harder. So one of the other differences that essentially comes here between a software engineering project and a machine learning project is when you're designing a machine learning project, and actually for that, I might just move on to the next slide. So when you're designing a software engineering project, once you identify the problem, you go to the design phase and you do a bunch of brainstorming, you explore different solutions. But in more than 90% of the cases, when you eventually come back to a solution, when you finalize 1 or 2 solutions that you're going to explore, you're almost 100% sure that the solution is going to solve the problem. It's only about implementing it, understanding the nitty-gritties of it, testing it, monitoring it, etc., etc. But once you have a solution, almost the entire uncertainty from the project is basically eliminated, which is exactly where it differentiates so much from any machine learning project, where even after having the right design and the right solution ideas to explore, success is not guaranteed. So you can always be at square one even after putting enough time and effort, which is essentially a very, very important point. It might seem very trivial, but you will be surprised how many people in the industry do not understand this. It is not intuitive for them, and which makes a job of an MLE that much harder, or a job of a data scientist that much harder to work with those people and to work in those companies. It's not just people, it's also company culture, and all the companies who do not understand this are essentially setting themselves up for failures, basically, because they won't be able to retain talent if you don't give them that room to explore and work with these and basically allow them to fail a little bit, essentially. So I think the major difference that happens is in this transition from design to implement, and this transition from design to this published result or like implement, there's like so many more uncertain blocks. There's so many more things that you have to think about and things that could go wrong that make it that much harder to estimate how much time it is going to take. Right. So one of the things we mentioned earlier was an ML project is becoming core to the business. So you have products which are driven by ML projects, which means you have teams, you have sales teams, you have business teams, you have product teams that rely on this ML engineering team to like deliver on certain timelines, because you're promising your customers a few things. And when that doesn't happen, it's both embarrassing for them, and it's also very hard to then build that trust between the engineering team and the associated teams of future problems that you're going to solve. So it's very important to have a very, very good idea of how would you estimate your project. So it seems a very trivial thing that, you always thought that the hard thing about ML would be finding the right algorithm or finding the right data set or the right problem to solve, but it's actually how do you set the right expectations. I think that's one of the hardest problems to solve in ML, is the people you're working with, how do you set the right expectations? Whether it is your customer, whether it is your manager, whether it is your product team, it's very, very important to have a very, very clear set of expectations that you can expect from a project, and the timelines, and the fact that even after doing everything that you are doing, there is some positive probability that it might not work out, right? So this is something I wanted to highlight. And then, as I mentioned, there are external factors. Like I've been talking about, there are very few people in the industry who have experienced that. This industry is basically 4 to 5 years old. And there are no frameworks or tools that exist for helping people out. You hear about agile methodology or like waterfall, and there's so many other ways in which software engineering projects are managed. And there are products dedicated for that, like Jira and so many other products out there. There's nothing like that for managing an ML project. Leave with product, like people don't know what framework they should use. A product is a very far-fetched idea at this point. So, and just all of this makes it very difficult to like time box it, and hence build that communication channel with people that you're working with, which makes it even harder for inexperienced engineers. So you're someone who's in your second year, third year, planning to build a career in this. Some of the first challenges that you will face when you actually get a job in it is your manager will come and talk to you and like, okay, can you do this in 4 weeks? And you have to give an answer, yes or no. And you have no idea because you don't know. Because in college, it was always about a class project. And what you get as a PR accuracy is what you get. And that is what you put in your like final paper. And you get graded based on that. But this is not a paper that you're getting graded on. This is like an actual product. And people are going to use it. And it is going to affect people's lives. So you need to come up with an answer, with a definitive answer. And somehow figure out a way to stick with it. So just wanted to paint the picture here. These are basically, at this point, probably, I've told it enough number of times, but for the one last time, these are challenges that exist in an ML job. All of them might seem very trivial, but trust me, they're not. These are real challenges that real engineers face in their day-to-day lives, even in a place like Silicon Valley. I have worked with enough engineers to know that this is a problem that a lot of them face. This is not a problem that only engineers face, but a lot of managers face, a lot of companies face. And you would be in a much better position in your career overall if you can pick up these skills as soon as your career as possible. So I'm going to now transition into, given that you know that these problems, what can you do now so that you prepare yourself for success, set yourself up for success, and gain as much experience as you can before you are into the industry, basically. So as I've already touched upon some of these points, I'll quickly just go through these, and Umang, you can feel free to share some of these slides with the student group that you want to. But the idea here is, as I mentioned earlier, you need to have a very, very fundamental understanding of the problem. And what I mean by that is, let's say, for example, for abnormal security, I'm trying to build a spam detector. I need to really understand what spam means for my customer, right? I need to know what people think of spam. I need to know, why am I not able to do it right now? Who is able to do it right now? How are they able to do it? I need to have at least some idea of all of these questions, some broad strokes of answers of all of these questions. Once I have that, then I need to understand what data do I get for it. One of the most important things that I believe for being a successful ML engineer is to be very, very handy with data. Is to have the ability to be very, I would go to an extent and say OCD about data, right? You have to be obsessive about patterns in your data, about things that do not look right in your data, and pull strings and pull the right strings to find answers. If two things don't add up, don't just assume that that's how it is. Ask questions. Ask questions, why do they not add up? If you don't find answers, dig into the data to figure out why do they not add up. And the more you get into the habit of doing that, the better machine learning engineer or a data scientist you will become, because you will always have a better hypothesis than the other data scientist to know why something will work, and when something does not work, why something did not work. So even though even if you're using like a deep learning model, which everyone believes to be a black box, which is true, even though you treat it as a black box, you will have a very decent intuition of when it should work, when it should not work. And the vagaries that you see in the data will help you actually inform the next steps that you should take. As I mentioned, I think this is one of the most important, the third one, which is the ability to identify risks in your project. The ability to identify what parts of your project are more susceptible to failures, and hence, how can you actually mitigate these risks? if you don't do this whenever you start a project, you're basically setting yourself up for failure. It is like you're basically relying on luck and a random chance to make sure that whatever design ideas you came up with or whatever solutions you're trying, one of it will just work. And if it does not, you would have no backup plan, or you would have no idea of what to do next. And if you don't plan it well enough, let's say you're doing like a 1 month project, right? For example, I was working on a recent project where we were doing at like email similarity matching, etc. And the project was fairly complex. And if I basically stack my project such that all the hard parts basically come in the end, I might end up spending about 4 weeks out of the 5 weeks that I have allocated for the project, and still not have realized the failure that I'm about to face in the project. Which means that at the end of 4 weeks, I have nothing to show for. My project has failed. I have to go back to the drawing board, and I'm not wiser. So that's a very, very bad position to be in, and that's why it's like very, very important to actually front load most of the work that you believe are the potential risks for your project. And what I mean by that is identify these risk modes and then try to identify either ad hoc solutions or like some ways of mitigating those risks, or identifying the go no go criteria, which is basically the next point for these risks, so that early you can determine whether this is a project worth pursuing, whether there is a solution that's possible for this project. And these are like real life hacks. This is not something that looks nice on a presentation, but these are actually real life hacks that many engineers like me, and I'm sure like better engineers than me, use it even better in their day-to-day lives to be more effective at their work as machine learning engineers, and to handle all the uncertainty that I talked about so far. And I think the hardest of all, which I believe is the most unintuitive thing for most people, and this is purely my philosophy, so take it with a grain of salt, reject it completely if you may. But I strongly believe in this. The hardest thing of all as a human being is to actually avoid emotional attachment. All of us, once you write the first line of code of a project, you are emotionally attached to the design that you are that you have started working on, or the experiments that you have decided to work on. And it's very difficult. And then what you're trying to do is actually find the data that justifies your intuition rather than the other way around. So do not fall in that. It's very, very important, because as soon as you start falling into that trap, it becomes very important. It becomes extremely difficult to get out of the several rabbit holes that this will take you into, and you will basically adversely impact your career if you're not able to manage this. Be very, very objective about the problem. Treat it as a problem. So if you are a doctor, you have to treat every patient like as a patient, and every medication you're doing as a possible solution to that patient. The moment you start getting attached to the medication that you're giving, you are basically not caring about the patient anymore. So I don't know if that's the right analogy, but really your job is to actually make sure that the patient is better. It doesn't matter what pills he take. So don't attach yourself to the methodology. Think about the problem, and always keep thinking about the problem. With that, I think I can close out the entire ML project. That was a little more theoretical, I would say. Unfortunately, I didn't have a decent case study. As I said, this is a very, very new thing, and any case study would make me devolve some information that I'm not sure if I'm allowed to. So, but I'm happy to answer questions later on, and maybe dive into some examples at the end of this presentation. So before I move into what skills you need and how did I make my transition, I think it's important to motivate what are the different roles available in this industry. So at least in my opinion, there are 3 broad categories of jobs that you can find in this industry. So one is data analyst, second is data scientist, and then the third is machine learning engineer. The reason I say data analyst is not defined, and I'll come back to that. So in a typical setting, a data scientist would be expected to do a bunch of data wrangling, just dive into the data, figure out trends, run some very basic models like linear regressions and logistic regressions, and then publish interesting and actionable insights, right? So come back and have a discussion with like the product team to define the next product strategy, which would then flow into engineering team and the machine learning team to identify the next set of tools and product improvements that they have to do, feature identification, development, and feature engineering. And one of the points that I've missed out here is dashboarding, metrics tracking, etc. So there are one suite of companies that will describe that as a data scientist job. And then naturally, then what follows as a machine learning engineer job is basically the people who own the the actual algorithms, the actual feature engineering, feature pipelines, actually training the models, productionizing these models, publishing these models online, maintaining these models. I don't think that is something you're taught about at all in your schools and like curriculums that you take. It's not just about one model that you build and like push it. You need to now maintain that model, right? And maintenance can mean very different things, as your infrastructure changes, as like your company situation changes, as your product behavior changes, as your customer expectation changes, and then also monitoring those models. And these are again two factors that not a lot of people talk about, and these are also like good skills to have. These are things that people will expect you to know, and expect these questions even when you sit for a machine learning engineering interview. There will be some flavor of this question where the companies are basically trying to gauge, do you know how to actually maintain models? Do you know that whether that is even a thing? And then how would you actually monitor the system that you have designed? Because that basically flows back into, if you can monitor it well, only then you can think about the next set of improvements that you can make, and then cycle continues essentially. So that's like one broader suit. I think this is one of the most prevalent ways in which data scientists in machine learning is used, at least in most of the tech companies. So most companies that identify themselves as like tech companies, this is basically the paradigm that you will see. And then some, I would say, not so tech companies, or where tech is not the core product, or companies who still don't understand machine learning and who still don't understand building products out of machine learning systems, basically have a slightly different system where data scientists are actually the people who train models and do feature development and feature engineering. Data analyst, then basically that role becomes relevant here, where then these people become the people who actually helping the engineering team monitor the system, generating dashboard, become the product license with like the product team, etc., etc. So the bridge between engineering and product. And then the machine learning engineering job here kind of becomes a more software engineering role, where you're actually looking at scaling the models, productionizing the system, distributed systems, or maintaining it as a service, or building distributed data pipelines, feature engineering tools such that your DS team can become more effective. The reason I introduce all of this is so that you have an idea of, from the position that you are in right now. So if you're already a software engineer and you're thinking about transitioning into machine learning engineer, maybe thinking about slowly getting into working with the team that is responsible for building models and helping them do things that you are very good at, which is productionizing models or the software engineering stuff. Help them do that, slowly try to get a foot into the door, understand how the system works, try to take small piecemeal projects from them so that you get more exposure to it. On the other hand, if you're a data scientist and you already know how to build models, you want to start working with the engineering team and figure out, how can I take small chunks of productionizing responsibilities? How can I make sure that I own my project end to end, and then start doing not just like building models, but also productionizing them? And that's basically what I did when I was transitioning from my grad school to actually being a machine learning engineer. And then at a very broad level, so I know I've skipped a few things here, and in the interest of time, we can take those in terms of questions, or maybe at the end of it, I can just give you a very brief overview of my journey as well. But this is basically, I guess you can find this anywhere on internet as well. But my idea of like what skills are expected from you, it's statistics, I believe, is something that a lot of people overlook. People think about building models and just focusing on learning the most fancy model, but statistics is a key part of your job. And if you're not good at statistics, I don't think you can be a good machine learning engineer or a data scientist, period. Like, if I'm interviewing someone for this role, for a data scientist role or an MLE role, half of my time actually goes on evaluating their statistical knowledge and the skills in statistics. I don't think you can play with data if you can't understand statistics. But that's just my very strong opinion. And then obviously what basic knowledge of optimization, linear algebra, you don't need to know this, but it just makes you a better engineer. If you know this, it just makes you a better data scientist if you know this. And it just helps you in that iterative loop of better identifying, better building better hypotheses, and being able to debug problems better. And then the others are just like skills that you already know. One of the things that I would like to focus on here is this last part. This is something I've seen evolve over the last 2 years in the industry, where a lot of the interviews now expect you to, they'll give you this 1 day project assignment or something. Essentially what they're trying to do there is they're trying to test how quickly can you train some of these basic models. Do you just know them in theory, or you can actually write code and quickly build these models and actually get an actionable item from it? So can you actually solve a problem using the stuff that you know, rather than just playing around with it as a project, which is the first thing that I mentioned when I started this entire presentation, which is the grow up time for ML has arrived. And this is exactly one of the key indicators of that companies are actually expecting you to build something out in a day or two. What this also means and how you can build this methodology. So this is the last slide, and essentially what you can take away from this is two things. One, if you are able to, at the end of whatever your learning journey is, able to answer questions for almost any problem that you see, what would be my 1-day solution to it? What would be my 1-week solution to this problem? And what would be my 1-month solution to this problem? If you can get good at thinking about a problem at that way, I think you've already become very good at managing a machine learning project, because that forces you to break down the problem into several parts, thinking about what is the most crucial part of that problem, and then evolving and thinking about what would be my ideal system for that problem. And then just to add to it, some intangible skills there would be data wrangling. I cannot emphasize on this enough. I have, I think, presented this many times in this 40 minutes, but yeah. And then metrics is another part that a lot of engineers cannot and do not have the ability to define. This was very surprising for me, to be honest, when I moved into this industry. I moved from a very management role, so I was very comfortable with metrics, but I realized that a lot of people do not intuitively think about metrics, which makes their job very hard when they're trying to define machine learning projects, because this basically flows into your go, no-go criteria, and then also monitoring the project, which are very, very important in iteration and improving the project. And then explainability and debuggability. I'm sure you would have had other sessions where people have talked about it. And again, I cannot emphasize on this enough. When I am building a security product, and when I actually block an email that does not land into someone's inbox, and if that was actually a work email or something that that person wanted in their inbox, I should have the ability to explain the behavior of my system. That is the only way that someone can have trust in my system, when they give me access to every single email that's coming into the system. And you should take a moment to actually really digest that we believe all of these are black box systems, but the ability to take a step back and think, how do you make these black box systems explainable? How can you build your tools? How can you, and I don't have that right now, but it would have been a very nice thing to actually show how we have built this entire threat portal that we have at Abnormal Security that allows our customers to actually walk in and then in a very human readable way understand why do we think that the specific email is actually a malicious email or would be a threat to your organization, or why do we believe it is not like that, which gives them a lot of confidence when they're using our system. So I guess that's it. I know I went slightly over time, so I'm willing to extend it by another 5-7 minutes if folks have questions. Come on.
Thanks, Saahil. I think that was a pretty comprehensive session, given that you covered from the project timeline to skills and everything. I'm sure there's a lot of things which students have learned from this. One thing I would do is I've opened the chat already, so students can now ask any doubts they have. Okay. First thing, Saahil, you had mentioned about the differences. The key thing, which is how a normal software development project works versus machine learning project works, and whereas I believe in the software development, of course, problem is common in both. Design is part where the machine learning project gets fairly complex. You have design, you also have software design, then you have machine learning design, and along with that you have data wrangling and all those things. And then you have all those checks and everything else. So in usual, how does say a company's time, if I have to take, percentage wise, so how much percent of time is kind of spent in the design part versus implementation part, like the big box you showed of the complex structure versus the other one?
Between software engineering and machine learning. I actually had a link in that presentation. I will share that with you, and if you can drop that into the chat for this YouTube video streaming. I think that link actually describes very well of the emphasis on design to answer your question. I think at least for machine learning projects, and I think that also is true for software engineering projects in general, if you are very clear on what your design is, if you're very clear on what your solution is, implementation is the easy part. And that is true in more than 90% cases. Again, so you have to be very clear on what your design is, what your solution is. So think of it as if you're a student, right? You're writing an exam, let's say you're writing a JEE exam, and you have a question in front of you. once you know what the solution is, actually writing it down, figuring it out, and solving the math is the easy part. The hard part was to figure out what trick to use to actually demystify that problem and then make it simple. So that aha moment basically has to happen in the design phase, and we have a very comprehensive design doc that at least we use at Abnormal, and then I think that is also open sourced in that blog post that Jesh has written. And I think for me personally, it has helped me a lot to really think about the problem upfront. So a lot of these things I was mentioning about risks, data, metrics. So we have designed our entire design doc such that even before you start working on a problem, you answer enough questions so that you yourself are confident enough that that is a project you want to take up. And then we have a lot of discussion around this design doc. So typically we would spend about at least like a week just in the design phase. And the more, and I would say I still complain with my manager and then Jess, and I'm like, we don't do enough in design phase. We still rush things because we are a very, very fast growing startup. And we have this constant pressure of like shipping out products. But the more time you spend on design phase, the better it is.
Coming to the aspect where you had mentioned, people use still, in software development, there's agile, there's given defined structures. Do people, and this phase is still evolving, right? So do people approach with agile and end up doing mistakes? Is that somehow counterproductive in things, or how is it? Because as a student, I've heard of these things only. I haven't even, as you rightly said, right? I haven't even heard of what other ways are. So I think students could benefit from that.
Yeah, I guess I'm actually not the best person to answer that question because I have never been a software engineer before this. I have only been a software engineer in the sense I've only been a machine learning engineer. And in my 3 years of experience, I haven't seen any of these methods or frameworks being effectively used. So when I was at Walmart, it was just horrible, to be honest, the way we managed data science projects. And it's not about Walmart. I mean, it's not a statement on Walmart. It's essentially, it was so new, and the company, we were trying to solve problems for Walmart store, right? Like an actual physical store, and you're trying to run the physical store using machine learning algorithms now. And it's very difficult because everyone who was there was just so inexperienced to understand how do you manage a project. And that led to constant pressure on the team, burnout from the team. We had like attrition at some point. And so I haven't really seen these methodologies being used in the correct way. Even at Abnormal Security, I've been here for 7 months, and it has only been the last 2 months that we've actually started actively using some of these frameworks. And we're trying to learn from our peers who are in the engineering team and try to understand how we can better use this tool for our use case. But I don't find them to be as effective. It's hard, right? Because you have like a task that either are in progress or like completed. And that's not how an ML system works. Like you might have completed a task, but it might still, the whole thing is still not done because it failed and you have to now redo and do experimentation. So that cyclic thing is not captured well in any of these tools. And those uncertainties are not captured well. So the answer to your question, I don't know if we use it right or wrong, but yeah. Yeah. Absolutely. Yep. Yeah.
Okay, I was muted. Sorry, I will just ask that again. So Madhur has asked, what was the reason for the shift in your stream?
Okay. That's a question I get asked a lot. To be honest, I had my dream job out of my college. I loved my job at ITC, and Umang knows it. We've been together through that, and it was fun. But there was a time again, as I was talking about that entire timeline. There was a time in about 2016 when all my friends who were here in the Bay Area, in the Silicon Valley, doing this machine learning, and I started talking to them, and I realized that there's this really cool thing that's happening in the world, and I could very clearly see that this thing will become the bread and butter of like the next business evolution that will happen. And I always felt that there was this entire software engineering cycle that happened in a career that I completely missed out on. I was always so afraid of software engineering because I came from a small town. never had access to computers. When I first did it, when we were at IIT, I still remember our first CS class. It was horrific. Uh, there is not a worse way to teach CS 110 like a first C++ class in that. And it was just so bad that it just drove me away. So I thought of machine learning as a very, very good entry point for me to once again give it a shot and see if the space is for me. And I was hearing so many cool things from all my friends who were doing this, and they made it seem doable. So when they broke it down for me, I realized, wait, I can do that. I don't know how to code, but I do understand the logic. And then it's the only matter of converting that mathematical logic in a language. So it's like learning any other language. And I got the opportunity to do that, so I took it.
Awesome. So I think a lot of students would relate to that, and this is something they could look up to, because that's a lot of uncertainty is always there. But of course, you have to get started and then get working on that. So Brat Kishan has asked, so what are the important operations related to metrics which should be known in the job?
Can you repeat that question?
Sure. So Brat Kishan has asked, what are the important operations related to metrics operations? Essentially, you had mentioned about the use of metrics, right? Which should be known to students.
I'm not sure if I understand the question correctly, but just to clarify, when I was talking about metrics there, what I mean by metrics is product metrics, right? So let's say, for example, let's say from my current job, when I'm at abnormal security, the metrics that we are looking at is for every attack that I catch, how many misjudgments does my system make, right? So like how many false positives does my system introduce? Because every false positive that we introduce is essentially a disruption into somebody's workflow. For example, for us to have this meeting, if the calendar invite that you sent me would have gone into my spam, we would have not have had this meeting, right? So similarly, there are different product metrics that essentially affect your business, affect the behavior of your system, or affect the performance of whatever model you're trying to build. That is what I meant by metrics. And these metrics can change a lot depending upon what system you have. For example, if you're Google, you're optimizing very different metrics. Fortunately, I'm in a business where I don't have to make people click on things. I have to stop people from clicking on things. So, so we are trying to optimize for a very different thing, basically. I don't know if that answers the question.
Cool. Yeah. I think the question might have come from metrics, probably operations point of view, but I think,
good. To answer that question, I would say cover that base. If you're thinking about matrix operations, I think there was one slide where I mentioned about linear algebra. And I think a fundamental course of linear algebra, I would say, is a must for being an effective data scientist or a machine learning engineer, so that you don't start using those tools as a black box and actually understand what's happening under the hood. So that in cases when you have to read those things, you are capable of doing that and not scared away by it. And then if you can, maybe some advanced course in linear algebra, which has some overlap with optimization, typically they do, would also be a very good addition to your tool.
Jumping on to probably the last question, or second last, Arnav has asked, what is more efficient and productive in a ML project, working on it alone or ML engineer? Or working as a team?
I think as an individual, as a career, you have to get used to working in a team, right? You cannot build companies working alone. You cannot build scalable products working alone. So I would highly emphasize on the skills that are required to work as a team. But while you do that, also try to figure out what individual skills you want to learn. So if I understand correctly, the motivation behind the question is, I can do everything if I'm working alone, and I get to do only parts of things if I'm working in a team. I guess that is the trade-off that you also face in a company, and you should be okay with it. There are always times you can take individual projects when you feel you are comfortable enough. What I have seen in my experience is working in a team when you have people with complementary skill sets makes much bigger projects seem doable. So you are willing to take much higher risk. You are willing to solve much challenging problems, which gives you then the confidence to actually do much bigger things. And you might not be doing those exact things. Maybe your teammate is doing it, but watching them do, learning from them, and that then falls on you on how effectively you use that opportunity of working with somebody who knows how to solve these problems and how much you learn from them. Whereas when you work alone, there are other benefits of that. You get to do a lot of things yourself, but then the problems you will try to tackle are also smaller because there's only so much time that an individual can commit and there's only so much knowledge that an individual has. So I would say do a mix and match, but try to focus on your capabilities on working as a team.
Does time permit to take one more question, Sahil? How's that?
Yeah.
Cool.
I ran a bit over, so we can do that.
Okay. So Hemant has asked, sir, I am pursuing my BTech in artificial intelligence and I want to work as machine learning engineer. So is it necessary to go for masters in machine learning before I land my job in corporate?
So I see actually two underlying questions there. One confusion that I would like to clarify is, at least in my opinion, AI and ML is one and the same. It's just different people use it in different ways. And there's just a graduation of the algorithms and the tools that you use that you want to classify as AI versus machine learning. Machine learning is a more, and actually there are people who just kill me for making that statement, like MLE and AI same, like machine learning and AI same. But fundamentally, for all practical purposes, they are. The only time to differentiate that would be to really go into technical reasons of what's really AI, what's really machine learning, and then the roots of machine learning versus the roots of AI. But let's not get into that. So for you as someone who's doing a BTech, I would say don't think of it as like you're doing a BTech in AI, so you need to do a BTech in machine learning engineering. That's not how it works. It is that ML versus AI is irrespective. It's about what skills you learn. And then to answer your actual question about masters versus BTech, it is not necessary to do a master's. I don't think so. The only reason I went to grad school was because I was from a non-CS ML background. So the only way for me to learn those skills was actually to get that degree and get some stamping as well as get some exposure to this field. If you're already doing a bachelor's in machine learning or AI, you should use this 4 years at maximum to gain all the skills that you can. And then at the end of the 4 years, you should ask that question to yourself whether is master's the right direction or is master's the right way of giving me that extra boost in my skill sets, or is job the right way of getting that extra skill? I am somebody who would always recommend taking a job, get that 1 or 2 years of experience, understand what you know, what you don't know, what you need to learn, where the industry is headed, so that you can use all of those as an input to then making a decision when you're actually going for masters. Because it's an expensive thing, right? You're going to spend 2 years of your life, probably some money on it. You want to make sure you make the right decision and a well-informed decision.
Right. So I think we would rest the questions here then. And thanks, Sahil. It's Saturday, kind of late night over there, but still taking time out and joining us here. So, any parting words? Anything you would want to leave the students with in their career they should have, or anything to add on to what you have said?
Nothing much. I would just say be very intentional about the decisions you're trying to make when you're trying to go into this ML career. Don't do it because right now that's the best paying job or right now that's the coolest thing out there. My whole agenda of presenting this to you was to give you another side of the story where there are real challenges in this. It is not as easy. I've seen software engineers, I've seen data scientists trying to become machine learning engineers get burnt out in 3 months, 4 months, and then go back to what they were doing before. Leave others. There was a time, actually like about a month ago, when I was doing all machine learning projects, and then I went to my manager and I was like, you know what, I'm tired of training models, I'm tired of doing data wrangling. For a month, I just need like a pure software engineering project. For a month, I just need to do something where I can be certain about what I'm working on, what the outcome is going to be, and the problem is on, and I can just find a solution. So that happens to everybody, and you need to then think for yourself whether this is for you. So try to use this time to like explore and figure out if this is the right thing for you. Life is too long to stick with one thing. I was in one thing before I realized this might be one other thing to try, and you can keep moving around and trying different things, and there's still enough time in your life to then excel in that one thing that you find.
You should be open for opportunities. You should look at what's working out well for you and then try to work as for that rather than just keeping blinders and not looking at anything else. So,
You did a much better job at summarizing.
no, I just took it and just added so that, yeah, I mean, the message is conveyed. But yeah, I think that is something a very strong message, because usually as a student, we always are uncertain, right? And we always get fancied by things and others. So, coming from someone who has been through that, and I know that how have you, gone through different routes. So definitely these are the things which weigh a lot, coming from someone like you, that these are, how to be essentially getting preparing yourself for the future. So
I hope so.
thanks a lot, Sahil. Thanks.
Thanks for inviting me. It was a pleasure to come and talk to you again and just speak to all the students who are excited about the products that you're offering them. Awesome. Yeah.
Yeah, was Sahil. He had an interesting journey. He, from mechanical with almost no coding, he is now working at top companies with machine learning complex projects and at the forefront of technologies. So yes, it is doable, but it definitely is not easy. Okay, and I hope you guys got to learn from his experience on how machine learning projects are being driven these days. With this, today's session or bite is actually coming to an end. The only thing left is the scholarship test, which is going to results which are going to be announced today. The winner would be announced, and a walkthrough on what Elite Techno Group's courses are for the scholarship students would be announced today from 4 to 5. The joining link, those who have filled the form would be getting it anyways, and we would be sharing it in the groups also. So if you have any question which you would want to ask me, or there are some questions which Sahil couldn't take up, I will just see if we can do that. So yeah, so I think Hemant has asked, can I directly apply for machine learning job after BTech? The answer is yes, but yeah, usually the route is go with a data analyst job and then go for it progresses to data science role. So see how it fits, but different companies, if you are really good at in the college itself as a data scientist, then companies would definitely want to hire you, and good opportunities could come from startups rather than established companies, and from there you could go to established companies. So that could be a way of going further. Okay, so there's what is difference between machine learning and deep learning is Karthik has asked. So Karthik, usually deep learning is seen as a part of machine learning itself, where there's neural network and all those kind of algorithms are used. So means people do see them as different as well. Machine learning, people call it orthodox machine learning and deep machine learning. So like people interchangeably change things, but yeah, deep learning is mainly the neural network, RNN, CNN, and all those things, and machine learning is mostly some of the initial algorithms which were developed for machine learning use cases. So having covered this, I think we kind of are summing things up here. I hope you guys had good learning, you guys had good time throughout this bite, and yeah, with this I conclude things. Take care, keep learning, keep exploring, and keep growing. Thank you guys.